Hey everyone, and welcome to The Explainer. If you're the kind of person who just loves visualizing how your body actually works, well, you are absolutely in the right place. Today, we aren't just talking about, lifting weights or logging miles on a treadmill. We're zooming way in to the microscopic mechanics of your body in motion. We're going to completely unpack the hidden anatomy of your cardiorespiratory system during a heavy workout. Okay, let's dive into this. Have you ever actually stopped to think about what happens inside your body when you decide to push your physical limits? I mean, the exact moment you transition from sitting on the couch to, say, sprinting up a huge hill, your body is suddenly faced with this massive biological crisis. Your working muscles instantly scream out for immense amounts of oxygen to use as fuel. But that's not all. In the process of burning that fuel, your muscles generate carbon dioxide, which is literally a toxic waste product that has to be removed immediately, or your whole system just crashes. It is a brilliant biological problem of supply and demand. Section 1. The demand for oxygen, fueling the muscles, and clearing the waste. So, to solve this immediate crisis, your body calls upon its ultimate rapid response team. The very first thing that changes the absolute second you start exercising is your breathing. Both your breathing depth and your breathing rate instantly. It's like flipping a switch. Your brain automatically signals your lungs to take in more air and to do it much faster, just to maintain that oxygen supply and keep up with that rapid carbon dioxide production. Section 2. Inside your lung volumes, the mechanics of heavy breathing. Let's move to and see how this builds from the macro view of breathing down into the microscopic mechanics of your lung volumes. We all know we breathe faster and deeper during a workout, right? But what does deeper actually mean biologically? Well, it starts with your tidal volume. This is basically the volume of air inspired or expired during normal, relaxed breathing, what you're doing right now watching this. But as soon as you start jogging, your resting tidal volume naturally expands to meet your working muscles' craving for more oxygen. The whole baseline shifts to handle the load. But what happens when that light jog turns into a full-blown sprint? That is where your inspiratory reserve volume comes into play. When you're under intense metabolic stress, you forcibly open your airways and aggressively pull in extra air after a normal inhalation. Basically, you're dipping deep into your emergency reserves just to keep the engine running. Now, on the flip side of that equation, we have the expiratory reserve volume. This is exactly the opposite. It's the additional volume of air that can be forcibly exhaled after a normal exhalation. When you're exercising vigorously, you aren't just passively letting air out. You are actively contracting your core and your respiratory muscles to vigorously push out that carbon dioxide waste. You literally have to clear the room so you can bring more fresh oxygen in on the very next breath. And this brilliantly illustrates the beautiful, vital balance of the human body under stress. On the left side here, you have the inspiratory reserve volume, the act of forcibly drawing in life-sustaining oxygen to meet those intense demands. And on the right, the expiratory reserve volume, violently expelling toxic carbon dioxide before it can build up. It's this aggressive, perfectly choreographed push and pull mechanism that keeps you alive and moving at high intensities. Now, what's really interesting about this slide is the concept of residual volume. Because even when you push out every single ounce of air you possibly can, there is actually still air left over in your lungs. If you completely emptied them, your alveoli would stick together and your lungs would literally collapse, which obviously would be a pretty bad way to end a workout. So this residual volume is a brilliant biological failsafe, keeping your lungs propped open no matter how hard you're exhaling. Section 3. Pumping the heart, delivering the goods. So the crucial point is, drawing all this oxygen into your lungs is completely useless unless it actually gets delivered to the muscles. The lungs are really just the loading dock. The heart is the fleet of delivery trucks. And just look at how rapidly this chain reaction unfolds. Step 1. The onset of exercise instantly stimulates your sympathetic nervous system. This fight or flight response leads to Step 2, causing your heart rate to spike, which then, Step 3, rapidly delivers oxygen-rich blood straight to your working muscles. And boom, in seconds, Step 4, those high metabolic demands are met. But here is where the real magic of consistency comes in. A stronger heart pumps so much more efficiently at lower rates. When you regularly subject your body to this kind of cardiorespiratory stress, the heart muscle adapts. Because each pump pushes way more blood, your heart doesn't have to beat as often. And that results in a significantly lower resting heart rate and way faster recovery times for people who exercise regularly. Section 4. Long-term exercise benefits. The ultimate payoff. Let's zoom all the way back out to the macro view for a second. When you consistently challenge this system over months and years, you achieve some triumphant real-world performance optimization. You strengthen your respiratory muscles and genuinely increase your functional lung capacity. You fortify the heart muscle and drastically improve your overall circulation. And because your oxygen delivery is now highly efficient, your endurance skyrockets, allowing you to sustain way longer activity. Plus, of course, you're actively burning calories for weight management. But the most profound takeaway goes way beyond just athletic performance. Regular cardiorespiratory exercise acts as the ultimate biological shield. It lowers your blood pressure and actively reduces the risk of heart disease and stroke, basically protecting your long-term health from severe obesity-related diseases. So, I want to leave you with this provocative thought as we wrap up this explainer. How will you challenge your cardiorespiratory system in your next workout? Now that you can actually visualize your tidal volume expanding, your heart racing to deliver that oxygen, and your biological engine literally upgrading itself in real time, I really hope it completely changes the way you view your next sweat session. Use this knowledge to push your limits intelligently. Thanks so much for learning with me today on The Explainer.